In this experiment, we took some data in order to work out the value for the ideal EMF of this cell and also what its internal resistance is. So if you do that and you plot a graph of the terminal PD against the current in that circuit, we should get a straight line like this. And in this case here, the gradient is equal to minus R and the y-intercept is equal to the EMF. So this is the data that we've got. And what I've done is, to save a bit of time, I've plotted it already. So here I've got values for potential difference and also values for current, like that. Maybe it looks a little bit messy, but I think this is because I started at 1.24 and then I wanted to go up in even intervals like this. Now, the first thing we need to do is draw in a line of best fit. We can see just it happened to be that when this experiment happened, we got a lot of data kind of quite close together, and ideally it would be better to have a more even interval, but I guess that's just the way that the data came out. I'm going to put the ruler here. We're going to get a line of best fit, which I reckon is going to look a bit like that. Okay, so now we need to work out the gradient and also the y-intercept. Well, actually, the y-intercept is pretty easy to read off because we can see that this is at the origin. And so the y-intercept is equal to 1.50, and that means that EMF is equal to 1.50 volts, which I guess means it's a fully charged battery and exactly as we expect it to be. The next we need to work out is the gradient. So this is going to be equal to delta y over delta x. Now, I guess I probably should be drawing in a triangle as big as possible, but you can see it's kind of like it's not really there because it's kind of going on the axis, but we can still work this out. So the final value is 1.24. The initial value is 1.50, and this changes over, well, if that's 1, that's about 1.30, and that one there is 0. So we've got a small number take away a larger number, so that means it's going to be a negative value, which is what we'd expect. In here, this is equal to minus 0.20. Now, that is the value of the gradient, but the value for the internal resistance is going to be the negative value of this. And that means R is going to be minus that, which is plus 0.20 ohms. So in this case, we've got a small cell, it's got an EMF of 1.5 volts and an internal resistance of 0.20 ohms.